All right, so we're back after having went through the troubleshooting. We established that if you've had a mess up in your database build out here, if you use like a different name than what it actually is supposed to be, or anything like that, because of these volumes, when you take your the instance of these containers running down, you have to do a docker compose down -v. Docker compose down -v. The -v brings out the volume too. So when you do that, it will bring down both the images and containers and also the volumes. It will bring down, that created a volume. Here is our down. So it's removing all of these. It's removing the volume and everything. That's all we had to do. We had it right this last time here. So everything works together. I've tested it over here. We can see now when we go to owners that it is, the database was accepting connections, and now my server is logging as well, and I'm getting data back. Okay, phew. So we have this Docker compose file that's spinning up both those containers for us and running them. So now I can just package up these images and put them somewhere publicly. So then if anybody has a compose file like this, all they have to do is run the compose file. And as long as they have access to those images, it should work, right? They don't need the rest of my code. As long as they just have, like if we look, as long as they have access to these two images, then they can run a Docker compose on their own computer. Just instead of using build, they're going to use an image name, much like we do when we build our Postgres one. We're basing it off an image. Well, I have two images here that as long as I run them, or then they work together perfectly. I don't have to build new images. I have two that work. So instead of now building, we're going to change our Docker compose to use these two images and run the same thing, but based on those images that we've created. Okay, so instead of building, we're going to just change these to run on an image. Now, how do you think I specify what images we're pointing to?
Do you use that image ID?
So we would probably use, like when we go to this and we base it off an image from an image in these Docker files, it's like the name, right? So we point to like the name of these images, but it is kind of confusing. Like, what do we use? Image ID, the repository, like we don't know how to really point from our computer. We know how to point to images though on Docker Hub, right? We just point to the name of that image on Docker Hub. So I'm going to do the same thing with our Docker Compose, except these images are here. I need to push them to Docker Hub so that I can refer to these images from Docker Hub. Okay, so doing this is super easy. We need to just give it a tag, which is a new name, and push it to Docker Hub. So we have these two images. We're going to Docker tag, and we're going to name it pretty much the same thing. Well, Docker tag, we're going to grab what we're going to push to Docker Hub, is what we're doing first, and then the tag, the name we give it, it's going to be the second part of the command. So we're going to start with pet startup API. Sure, it can have the latest on there, doesn't matter. And we're going to name it your Docker Hub username / whatever you want to name it. So I'm going to call this pet API. And then good practice is to put in a version 1.0.0, your first version of pushing this to Docker Hub. Version gets important when you do multiple pushes of your image to Docker Hub. Okay, so this is saying take this image that I've built locally that works, and we proved it works, and push it to Docker Hub using this name. So when we run that, it's going to think for a minute. I think for a long time it looks. And then it did something. We're going to say that hopefully it did it. We'll go check in a second and see that it did, in fact, push it to Docker Hub. But for now, it didn't give me an error, so I'm going to think it worked. Now let's go do the same thing with our other one. Instead of pet startup API, now we're going to target the second image we've created, which is our database image. And now I'm going to name this one pet database. Okay, so Docker tag, and this is just creating, sorry, this is not pushing to Docker Hub. This is creating a new image with that new name. Okay, so there we go. Now let's do Docker images, and we can see we have all of these images now existing in our images. We have the ones we've run locally, and then we have the ones that we are going to push to Docker Hub. Okay, so now we can push these to Docker Hub. Let's see, I think we have the, yes. So it's super easy in the README. It says, once you're logged in, which you should already be logged in, nobody should be logged out if we've done this push to Docker Hub before, then we're gonna, we've already built these. We've got these images built. Sorry, that's not the command, but we're gonna Docker push these images. Okay, so it's literally just Docker push. Okay, so we're gonna push the ones that have your username in their name. So Docker push, Tiffany Joel pet API. Okay. I guess it pushes using latest. That's fine, whatever. And then we'll Docker push Tiffany Joel pet DB. Okay. And it looked like it worked. So let's go into Docker Hub here and make sure that we can see these new ones pushed. Did it not push? Come on. Do I have to log back in? First to tag does not exist. Let's try it with latest. Wait. Okay, that's what I had to do with the 1.0.0. We have to, I had no latest, I've set it as 1.0.0, so let's do that. 1.0.0. Don't worry, the README will be updated so you can refer back to it. So we created these images locally, we worked them together in our Docker Compose. Now we are preparing these images to push to Docker Hub so that now in our Compose we'll just refer to these public images instead. Okay, so now let's come to your, yay, so these worked. Now these two images are public. So anybody who has that Docker Compose file can now refer to these image names and it will run that Docker Compose using these two images to build the API and database. Okay, so and how we can do that, how we can test it to make sure it actually does work, is we will change these instead of saying, pointing at the at your build, we're going to point to the image names, which was Tiffany Joel is what I have. Y'all can actually even point to these directly. Control C, this image. So that is the database one. And then the other image I made here was pet API. Okay, so now when I run this Docker Compose, instead of using my local Docker files to build images, it's going to pull down these public images that I push to Docker Hub and use these to build everything. Let me go ahead and make sure we remove everything here before we try running this. So I'm going to Docker Compose down -v, make sure I don't have any volumes or anything happening over here. And then I'm going to try running this Docker file now pointing to these images. And this is important because our goal is to just take this Docker file and put it in our EC2 instance and kick it off. Once we run this Docker Compose up in our EC2 instance, it should reach out to these images we have on our public facing hub and just run. We don't have to pass in any other files with it. Okay. Now let's try our Docker Compose up, -- build. Oh, hang on, manifest unknown. Am I going to have to do 1.0.0 for all these? Maybe I should have just done latest, but it gets a little interesting when you're trying to pull down or push up multiple versions. Okay. So you have to identify 1.0 because I didn't just use the latest tag. Sorry. But it'll help you in your project's time frame. So you can see that when you go to the images, the only tag I have available is 1.0, whereas if it was like, let's go to like Postgres, which we've gone to Postgres. This image, holy cow, so many tags. So these are the tags you pull down. Remember, we put that like doc or Postgres :16 to identify the version or the tag we want to pull from our Docker Hub. Same thing goes with mine. I have a 1.0.0. Some things might have a latest version. Images. Others will have, you have to specify like an actual tag name or tag on the image, if that makes sense. Let's go back to mine here. So this has a 1.0.0 to pull down, but I think like this one has a latest. No, that has 1.0. This has latest. Okay, so you can only pull without a tag version as if they have latest, but mine did not have a latest, so we have to pull down referencing by that version. Okay, so when I did the Docker Compose though, it built and ran just like I had those images here, just like I built off of these, but instead it's just pulling an image, which is already built, and running them based on the information we have. And we can go here and we can hit this again and it'll work. Yay, because this is working. See, got that request there. All right, how are we feeling now? We're following along okay? We built our images locally. We have verified they worked together in our compose file, and then we pushed those built images that worked to Docker Hub and then updated this compose file to now just refer to those pre-built images. All right, so now is the part we're gonna, so ultimately, I don't want this running here, right? This eats up my terminal. I have to leave my computer on. This is not good. I don't want this running all the time here. So this is where we're gonna use our Amazon EC2 instance. And from here, we will pretty much follow the README verbatim to get it set up. So let's get that pulled up. We will be starting at this port here that says launching a server. Okay, so underneath that third, under launching a server. Do we want a break before we get into launching the server? I see a big yes. Okay, make sure we Docker compose down our stuff if you haven't yet. So stop your containers and Docker compose down -v preferably, so you bring down those volumes. And then we will take a break. Let me pause recording. Okay, picking up where we left off. We are now back together after a break to make an EC2 instance. If you are on our README, earlier in the README, it says that an EC2 instance is basically just like another computer. Okay, we're just going to kind of make another, like a virtual server, another computer to run our Docker Compose on, so it's not eating up our terminal and our resources. So y'all should have signed up for the AWS account. And once you're logged in, you'll be on this home screen, I think. I have visited it before, so I see this EC2 in my recently visited, but if you haven't, you can look for all services, or I think you can just search for EC2. And we're going to work in this EC2 virtual servers in the cloud. Okay, so from here, following along directly with the README, we are going to, and it says we're basically renting a computer here. To get started, in order to make one, we're going to have to launch an instance. So we're making our own little computer. In order to do that, launch it. So we click the button, launch instance. Once you click launch an instance, it should bring you to this, which is where the README has the screenshot starting right here. I'm in dark mode, the README has it in light mode. But in here, you can give it a name or a tag. Sure, we'll call this pet startup, I guess. And we're going to run it on a Linux server, which is, y'all should be used to. Commands in Bash are very Linux-ish. So actually it is Linux, isn't it? I forget. So we're going to be using a Linux server, and then we're going to be using, it should pretty much be on, oh no, we're not using, yeah, it's the default, Amazon Linux 2023 AMI. Okay, so should be the default. It's free tier eligible. This is going to be one of the smallest resources server that you can rent, basically. So if you need more, let's see, there's 618 and 61. We'll stick with that one. That was default. If you need more processing power, you can choose different servers to host your application. But that will also cost more. So that's what I was saying. Don't click around. Don't choose anything else. We're choosing this first one. That's most likely default. Linux 2023 kernel AMI. Okay, free tier eligible. Make sure it says 64-bit. For the architecture, again, it should just be default. And all that looks good. Next, we'll scroll down. For the instance type, this is also, again, where you can choose some more resources on your server, your OS platform. We're going to be just sticking with T3 Micro because, again, this is the cheapest. It's free tier eligible. This is one, look, so if you leave it running on-demand Linux pricing, it's going to be 1 cent an hour if you leave this running. If you're not within your free tier stuff, okay? Oh, there's even less. Let's see that one. Let's do this. We could probably do a nano. I bet a nano can hold it. As long as you still have free tier like resources, go ahead and choose micro. I'm going to use this just to see if it works on the nano. But these are the two smallest ones you can have. 1 CPU, very little memory, and it gives you the exact pricing for each thing. And you see as you get more resources available to you, more CPU, more memory, your price per hour goes up. So be careful with that. Do T2 Nano. Let's see. Y'all do T3 Micro, or if you have T2 Micro, if you have, let's see, what does our readme say? It says T2 or T3 Micro. Okay. All right, so that checks off instance type. Next, we go to key pair. So in order to actually get into your virtual server, basically, you need a key pair to get into it so you can connect to your instance. Much like when we exec into our containers in Docker, you could exec into your server you're renting here. So if you already have a key pair saved somewhere, you can select it, or you can create a new one. And when you create a key pair, you're going to give it a name. So this one's going to be for my pet startup app. And then we're going to do an RSA pair type, and we're going to use a PEM file. Okay, so these should be by default. We're going to create this. So this is where you're going to save your PEM file, is wherever you choose to drop it. Let's see. I am going to put this where I've been working in my repo. Where's my Ubuntu? Like my WSL. That should be down here. Hang on, let me bring it up on another. And I'm just going to copy the path and bring it in here. It's user, right? No, it's going to be Ubuntu, home, Tiff Joel, and then Juliet evening and weekend. I'm doing week 11, day 1. Okay, cool. No, not day 1. We're doing pet start. That's what we're doing. So where you save your PEM file should be somewhere kind of secure. So I wouldn't necessarily recommend doing this in like an actual organizational practice. I, for ease, am going to drop it in where my repo is for pet startup, just because I'm going to run all the commands here and I need access to that PEM file. So I don't accidentally like commit it to GitHub. I'm going to add like, we'll do .pem here. So nothing that ends with .pem just should go to GitHub. That would be bad. Okay, so I'm going to save this key pair to go into the pet startup one, and it's a pet startup PEM file. So now when I come to my repo, we can see I should have, yes, my pet startup PEM file. So it's going to look like this. It's going to be your private key to get into your instance of your EC2. So again, this is, oh, it's not ignoring it. I have to do star PEM. Okay, there. Now it's grayed out. So now this won't accidentally get committed to GitHub, because that would be horrible. We don't want secrets out there. This is a very important one because this is used to connect to our instance of our virtual server. So very powerful file to have. What the heck? That's new. Interesting. I haven't seen this created with the PEM file before, so. Well, it's in binary. We're gonna ignore this too. Pet startup. Get ignore. Let's do. All right, we're ignoring that too. I've never seen that created at the same time. It might be new. I haven't done this for a while. Okay, so I've got my PEM file. That was the next thing the README wanted us to do, was create that PEM and make sure that's the key pair that we're going to use to log into this instance that's running. Okay, So scroll down for network services. Under here, we are going to allow SSH traffic from my IP only. So this means only I am able to get into this computer to do deployments and working with applications and all that stuff. Nobody else can access my instance, only I can. So I'm only allowing it from my IP address. But we want people to make requests to it, right? We're setting this up so it could be like an API server that's giving out data. So we're going to allow traffic from the internet. In this course, we're only teaching you HTTP traffic, but in real practice, you will learn how to do HTTPS traffic, which requires certificates and all sorts of trust things going on between the two. But for now, we're just allowing HTTP traffic from the internet. So that means anybody can make a GET request to my endpoints and we will allow it. Okay, so after that, we shouldn't need to change anything else. We can just launch instance. And we will wait. It's going to launch my instance for me. All right, it said successfully initiated the launch of this instance. Let's go back to instances. And now we can see in our instances, we have this pet startup instance that I created running. All right, it looks like right now we need to do a config update because, let's see, front end code. Oh, yes. So when we go to our application here, we are going to eventually just run the server through Docker Compose in there, but we are still going to use our front end locally. So if we come look at our app.jsx, our fetches are going to our local host. Is that where this application is going to run on now? The backend, that server? No, we are running it in our EC2 instance. So when you click on your EC2 instance, it comes with a whole bunch of different stuff. The important thing to note is this public IPv4 address. So instead of going to your local host or 127.0.0.1, we're now going to do a fetch from this base URL. The endpoint paths will stay the same, but now it's being hosted on this URL. Okay. So I'm going to copy that address and I'm going to go back to here and I'm just going to change out all these local hosts to be that URL or that IP. And it's still going to be over port 5000 and to the same paths that we already had. The only thing that's changing is localhost. Okay, so now once I get my backend running on that instance, now my front end should be able to make requests to that specific instance. Okay. Let's see. So even though we are accepting requests coming in from everywhere, I can make a GET request from my server to that server. We still need to open it up so that that port 5000 can be accessed. So we need to do one more config change, and this is all in the README if you follow along. We're going to do one more change where we need to go to the security tab under our instance. So we click on security and we have these rules now. These rules tell what kind of traffic is allowed from where. So we have a rule set up already for port 80 and port 22. These are just included. Port 80 is our web requests. So any like front end web request, HTTP wise, is going to come in over port 80. 443 is the port for HTTPS requests, but port 80 is where just our normal GET, our fetches we're doing to the backend. Every fetch is going to come through this port, so that's why it's open for everybody. But we need to add, let's see, where do we add on here? Click in, then click add rule. Where is add rule? Uh, Am I blind? Maybe let's launch Wizard and see if that does it. Okay. No. Security group ID? Okay. Yep. Launch Wizard, security group ID, I guess. And then it will bring you in here. We're gonna do the inbound rule. Yep. And we're gonna edit inbound rules. Okay, edit inbound rules. Now let's add one. So don't mess with these top two. These are fine the way they are. But this one we're adding here, now we're going to allow all traffic over, like all traffic from anywhere IP, let's see, what is it? All traffic from everywhere, I think IPv4. Okay, so as the README points out here, this is not secure. Allowing all traffic from everywhere. But that's what we're going to do here to make it easy. You'll learn on the job, like what kind of rules you'll need to add for security reasons, but we're just going to allow everything from everywhere so that we won't get CORS errors when we're getting our server. I know, Brenda, look away. We won't get CORS errors, and this is just for learning purposes. We're going to deploy this app and just allow everything to come in from everywhere. Okay, yeah. So now port 5000 is open for, actually almost everything is open on our server to allow connections from everywhere. So we can see it successfully saved that rule. I think if we go back to our instance here, and we go to the security tab, now we should see all three of them. Yep. I don't even know. We probably could have just opened up port 5000 for source from everywhere, not everything from everywhere, whatever. Well, I'm pretty sure we should have just done port 5000 here, but we're going to follow our README so y'all can just look back later. Okay, so now that we're up and running, our instance is up and running, it's not quite ready to just throw our Docker Compose file in there, because think of this as like a brand new computer that doesn't really have any applications installed on it. So it doesn't know what Docker is right now. How we get into our little rented server is we connect to it. And when we come to the connect here, holy cow, they have changed how they do this. We're going to do it in an SSH client. Okay, so it's telling you how to connect to your instance of this server. We're going to do this in our terminal. We will open a client, which is going to be our terminal. We're going to ensure our key is not publicly viewable, and then we're going to run this command, this SSH command, to get into your instance. Everybody's should be specific to their instance, so it should have your instance information here, and it should have the name of the PEM file you'll be using to connect to it. So let's follow this here. Okay, I'm going to pull up a pet app. We get one on one side and we'll get something on the other side because I put my PEM file in here, right? Close all these out and just have one big terminal. Let me clear this. Ah. And then we're going to put this on the other side here. Okay, so let's make sure we're at the location where our PEM file is. And we are. So we need to be here. And don't worry, like I said, it's in the README. You could take your time to just walk through each step afterwards. We're going to get into here, into our server by how to connect. And we said, open an SSH client. Sure, we're going to do it through our terminal. Locate or download your private key, which we did. It's right here. Okay, and now we got to make sure it's not publicly viewable. So you need to run this command where your key is located. Okay, So it says it's not publicly viewable, and well, it doesn't look like anything changed, but if you don't run this command and you go to try to SSH in, you're going to get an error or something. So you need to run that first. Then you're going to copy this SSH command, and it's going to ask you, are you sure you want to continue connecting? Yes. All right, and then you should see this little bird, dove thing, whatever, and it will have your EC2 instance and the $, and you're within your virtual server, your other computer. We can ls in here because we said we wanted it to be a Linux server, right? So we can use all the commands we know how to use already. So we can ls, but nothing's there. What is the C hidden files? ls-a? Yes. So here are hidden files. We pretty much have just like a bare bones computer. There's nothing in here, nothing available for us to use. So we need to install Docker to be able to use that Docker compose file in here. So after like all these pictures showing you how to create your instance, set up your security rules, we ran our, making our key file obscured from public and SSH'd in. Now we need to install Docker, so we can use Docker Compose. And then the Docker Compose plugin. And then we need to install Git as well. Well, we don't need to install Git. We're not going to use Git, but we'll do it for now because I just want to copy this whole chunk of code and just pop it in my instance, okay? So just copy this. Don't even worry about understanding it. It's just going to install everything we need to make the things we need run in our EC2 instance. So this will probably take a little while here. It should run it fine because it has these. Yes, okay. It takes a little while to like start doing things. So don't worry if it's sitting there for a minute. Just be patient. It's gonna go through and install stuff and make directories and whatnot and chmod them to do executable on stuff and whatever. Don't need to know what this actually means. Just go ahead and use it to configure your new virtual server. We will just wait. Once it's done, we're going to verify that we can use Docker Compose because that's what we want. That's our main thing. We want to make sure we can copy our file in here and then just run Docker Compose and our application is up and running. All right, so we are done. Everything looks like it's installed. Let's do Docker Compose version and make sure we just at least get a version returned. So yay, Docker Compose exists in here. All right, here is where we are diverting from what's currently in the README, and I will be pushing the changes to the README later, like after class today. Okay, so that wanted you to copy your whole repo in here, but we've set our application up so all you need is that Docker Compose file, right? This Docker Compose file is pulling from public images on Docker Hub. So I don't have to copy anything else in there besides this Docker Compose file. So if I can somehow get that into this server and just run Docker Compose up -- build, my application is going to be running in here. And we can do that. I'm going to leave this up in this terminal, and then I'm going to come over to another terminal. And I think there's a command here that tells you how to copy things in. Let me see. Connect to an instance. Maybe there's not. I thought there was like an easy place we can see like copy commands, but that's okay. I will give you one. All right, let's go back to connect. Let's see if there's something here. No. Nope, don't worry about that in an SSH client. Okay. Well, I don't see it here, but you can see, let's do copy file to EC2 instance. Okay, so the easiest way to do that is using a SCP command, secure copy protocol. And we can see that you do like scp-i and then whatever your PEM file is, which we are in that location. So that's going to make this easy. And then which text you want to copy in, and then your EC2 instance location. So we can find our EC2 instance information here. This is the instance like directory / location that we are going to move the file into because we SSH'd into that location, right? And so we want to put that file right here, right where we're at. So we're going to copy it into the same location. Okay, so let's follow this command, which is scp-i. Our PEM file is called whatever you named it. Mine's called petstartup.pem, which actually, let me ls. I am not in the right directory to target that file. So let me get back out. Now I am. Now I have the PEM file available to me. So scp-i pet startup.pem. And then we want to give it the name of the file we want to copy in to our EC2 instance, which is going to be the Docker Compose file. That's all we need. So we're going to copy in docker compose.yaml, and we're going to copy it into this EC2 instance, your EC2 instance, okay, which is what we use to connect into it. You can specify, we can see that this specifies a specific directory, but I'm just placing it at the root level for ease of teaching. Okay, so we can see it looked like it did something. I don't know if it did. Let's go back to our other terminal where we're in our EC2 instance, and let's ls and see if that file made it in. It did not. Why did it not make it in? scp-i or PEM key. Oh, I bet I need to do this at the root level. Let me try this and see if that's right. Yes, okay. So you got to place it at the root level directory here. So just add on your command before, if you're following along, the little colon, little tilde, and the /. So now when I ls, I would expect to see it in here. We can see, yes, we have this file in here now. We've copied it successfully into our EC2 instance. All right, so now that I have my Docker Compose file here, what did we do to build our application locally? Just did a Docker Compose up -- build, right? And we can see it's pulling the images from our Docker Hub to go ahead and run our Docker Compose. It's going to take a minute to pull them. I believe we're going to have an error pop up soon, but we will see. That'd be cool if it just worked. Hey, did it actually? Okay. Yours might not work, but there's reasons for that it might not work, but mine looks like it did. It did. Created table. So now, if I want to see this running, remember how we went to localhost port 5000 and we're just pinging it in the in our browser? Now I would go to this one. We can open address and then make sure it's HTTP because we're using an HTTP connection. And then let's go to port 5000 and just the /. And we can see, hey, our server's working. It's hosted somewhere else, not localhost, somebody else's IP address, which is the server we're renting. And now let's go to owners. And we can see it still works. Yay, we got our data here. So now let's pull up our front end that we've made the changes to point to this IP address, this URL, and now this should talk with our server that's running. And let's go open up our live server. Okay, this one, live servers on localhost 5500. It's going to be weird at first. Remember, it needs to know where that index.html is, which is in our front end. Okay, so now I'm working with my front end locally using live server. When I click all owners, it should run the JavaScript that is now fetching from that IP address. Well, the all owners is up here. Ta-da! Yay, data that's not running on our local computer anymore. It's running in, so I could actually like kill this terminal now. That's my EC2 instance. It's running, it's doing its thing somewhere else, and this is working still because we're not doing it locally now. And when we do Docker PS, there's nothing running here because it's not here. It's in our instance, our virtual server we set up. Pretty mind-blowing, huh? Pretty sweet. So that is the lecture today. If you have issues when you go to run, do your Docker Compose run build in your EC2 instance, there might be an issue with build architecture. So I created this image here, and theoretically, when you create an image, it should be able to run on all architectures, but sometimes there's a difference because we built this on a Linux and a certain OS system, and maybe I built my images on a Windows. There's an issue. If that happens, the only difference is running when we built our Docker images locally, when we like did the Docker build before we did our Docker Compose. When we built these locally, you would do this command. Let me pull it up. It's a Docker build X command. I have to save it because I never remember it. I put it in the README that I'm changing here. Okay. So instead of running the Docker build and then -t and whatever you're going to name it, you would use a Docker build X and then specify the platform that you're building it for, your EC2 instance platform, which is typically this linux.ar. As long as everybody's using, like, I think the Mac is okay with it. I think it works okay. WSL, if you're on Windows and you use WSL, it's going to create it on this type of platform anyways, too. So I think everybody should be okay. But if not, let me know and we can check out and see if you need to run this build X command instead. Okay, so I will try, let me, first, any questions before I stop recording? Because I'm going to do like a really rough like list of what we're gonna walk through for how to get you all at this point.
Thank you.
Yeah. Make sure, so if you're not actively using this, like I'm done, I did mine, I got it up and running and showed y'all, so I'm gonna be done. Then go into your instance and where is it? They've made everything so much instance state. Terminate. Don't just stop, terminate it. Okay? Stopping it will still keep that instance there. You could still get charges. So terminate, delete your instance. Look, you could skip the OS shutdown if you want, but whatever. We're just going to kill this instance so I don't get charged for it. Now, when we come back here, you can see it's shutting down. Eventually, this will just disappear. So if you go into instances and see nothing, you're fine. You're not going to get charges. You come in and see something running, well, might have something pop up. Okay. I'm gonna stop sharing then, or stop recording.